Alright guys, one more video on Piecewise, and we're finally finished with all the videos for 1.5. We did parent functions, 2 videos on transformations, 2 videos on Piecewise. Alright, so this is part 2. We are writing equations given the piecewise graph. So the first one has 3 linear pieces. Now we can do this in 2 steps. I like to write all the the if parts over here. So the first piece goes from, let's see, -1, 2, 3, 4, 5. So from -5 to -1, and it included -5, and it did not include -1, so we need just a less than. I call those sandwich sentences, because you're putting the X sandwiched in the middle, and sandwich sentences always use less thans as you go left to right. Just a hint on that piece. Okay. Then we have a sandwich that goes from +1 over to +2, 3, 4. From 1 to 4, we have a new rule. And that one is included on both ends. So we could say X is between 1 and 4. And then over here, this third piece up here goes from 4 to the right. 1, 2, 3, 4. Yep, from X equals 4 to the right, but it has an open circle. So that would be X is greater than 4. Notice this actually doesn't have a domain of all real numbers. There's no definition from -1 to 1 in here. We have no points. Interesting. Okay. Now, the rules for this one are super easy. This piece, the y just stays at -2. So we have a big old -2. This piece, now this gets a little bit trickier. You can find this a lot of different ways. The easiest way for most of you would be to extend the line. So it's going down 2 and back 1, down 2, back 1. And write the equation of what that linear function would be. So it has a slope of up 2 and over 1, but it would cross the y down at 1, 2, 3, 4, -4. Okay? Since that one's pretty easy to tell what's happening, you can just write it that way. The other option would be to write down 2 of the points. We had 1, -2. And it went through at the end up here, 4, 1, 2, 3, 4. And then you could do the slope. And you would get 6 over 3 is 2. And then you could put in point slope. And you'd have and when you added 4 over here, yeah, what did I mess up, guys? Okay, the slope is 2, and it does go through the point 1, 2, 3, 4, 1, 2, 3, 4. So y minus, the point was 4, 4, so this should be a 4. All right. And then when you distribute, this is an 8. And then when you add 4 to both sides, you get y equals 2x minus 4. If you can do it by visualizing where it would cross the y-intercept, that's fine. But that was the long, complicated way. All right. And the last piece, we're in luck, is 1, 2, 3, 4, 5. It just stays at 5. Bing. Okay. I finally figured out how the calculator thing works. So I'm going to show you this one real quick on the calculator. What you have to do is go to y equals, if you're using the emulator, or a new calculator, and go to math, arrow up to piecewise. But you have to start in y equals, okay? And then you can arrow up and down on here. I was trying to push over here. You can arrow up and down on your calculator if you need more or less pieces, okay? So, or arrow left or right. This one has 3 pieces, so I'm good. I can arrow down to OK and hit enter. Look, it gives me all these little boxes. So I'm going to type this in. My rule I came up with was -2. Then you can just arrow to this box, but you still have to use that test menu. So it was -5, it's second math to get the less than or equal to, which is choice 6, then an X, then a less than, second math 5, and then a -1. Okay, you don't ever have to do this. This is just a way to check your answers. This line I have 2x minus 4, and it's between 1 and 4. So I'm going to type 1, second math, less than or equal to is what I have, which is 6, x, second math, 6 again, 4. Scroll down one more, and this is instead of the crazy divide in parentheses that kind of seemed like magic. This one you're actually just typing it in, x, second math, greater than, and then there was a 4. All right, let's see if my graph looks like ours. Okay, this graph paper was going from about -8 to 8, but how's that looking? Okay, now it's all the same color because it's all under the blue here. All right, you don't get pretty ones where the 3 pieces are different. All right, so that's how that piecewise thing works. I am going to just do the rest of these by hand. I am going to do, I don't know. I might have to do all these real quick, or maybe I should skip this one. Maybe I'll skip 2. All right, I'll do 3 with you. I'll go back and do 2 in the notes. Okay, so I like to do this part over here first. So the x's from here to here, which would be 1, 2, 3, 4, 5, 6, 7, from -7 to -3, and I'm sandwiched in between there. So it's a less than and an X in the middle. Now, this one was a solid circle, so the -7 gets a less than or equal to. Then the next piece goes from here to here, again breaking our domain, but from -1 to +2. This one again on the left at -1 had a solid circle. And then this piece started at -2 and goes off to the right, so x is greater than -2. But it is also an open circle, so it is undefined. If we had to write the domain, we'd have to say x cannot be 2. Oh, that's a +2, not a -2. All right, now to go back and write the rules, this one is pretty easy again. This rule just stays at 1, 2, 3, 4. The y values stay at 4. This rule is going up 1 and over 1. It's linear and it has a y-intercept of 2. So it's 1x plus 2, or just x plus 2. This piece, anybody know? That is a square root graph. Okay, that shape is a square root graph. This one has been shifted 2 to the right, which would be a -2 inside. And I don't think it's been stretched. Sorry about the bell, guys. We could graph it on the calculator and see if we get these values. I'm thinking it's square root of x minus 2. Let's check. If we type, I'm going to get rid of all this and just type square root of x minus 2. And then I'm going to go to my table. And it doesn't start until 2, 0, which is good. That's where mine starts. And then at 3, it's up at 1. That looks right. The next point it seems to go through here is 1, 2, 3, 4, 5, 6 is at 2. Is that working? Yep, 6 is at 2. So there was no stretch or anything funky. Okay, but again, you had to recognize the parent function of a square root graph. All right, that wasn't so bad. This one has 3 pieces. Again, I'm going to do the easy part first, to me anyway. 1, 2, 3, 4, 5, -5. And that rule goes until x is -1. X is sandwiched in the middle. And both are open circles, so I don't need any or equal to. Second piece goes from -1 to +2 here for the x values. So -1 less than x less than +2. But it does have solid on both ends, so both these need to be or equal to. And the last piece starts at +2 and goes off to the right. So x is greater than 2, and it has an open circle where that last piece starts, so I'm going to leave it just a greater than. This one does, the domain is continuous, but only from -5 to the right. So if we were doing the domain, this one would be parenthesis -5 to the right. All right, let's go back and fill these in. So the red one, this was a square root graph because it's this shape. Now, normally it starts at 0, 0 and goes through 1, 1 and 2, 4. This one is shifted left 1, 2, 3, 4, 5. So left 5. And I think that's all that's going on because the square root of 1 is 1, so it went up 1 and over 1. The square root, if you go over 4, the square root of 4 is 2, so it's up here. So I think all we have to do is a left 5 shift there. And that would be inside with a +5. Second piece is a line, and I think we're in luck. We can tell where all the intercepts are and everything. It crosses the y at 1, so we have a +1. And the slope is actually going up 3 and over 1, so 3x + 1. That one wasn't so bad. This last one is a piece of a parabola that opens down. So we have a negative and an x squared, but the vertex looks to be right here at 2, 1, 2, 3, 4, 2, 4. So we would have to say it shifted right 2, which would be minus, and up 4, but it's opening down. Now you could type this in the calculator and see if these points all work, okay, but they should work. So it's negative x minus 2 quantity squared plus 4. All right, I'm going to pause the video here and finish up in a second, but I think they're about to say the pledge. All right, guys, Hofbauer back. This one is basically finished. I was going to maybe talk real quick about the range just because it's good review. The range of this one, because it's going down forever, it is got values all the way up until here. So 1, 2, 3, 4, 5, 6, 7. From -infinity up to 7, and it had a solid dot up there at the top. So that would be the range. Doesn't matter that it's got broken pieces as long as there's values along the way. All right, I'm going to go back and do the one I skipped here real quick. If you want to think you're done with the video, that's fine with me. All right, so x values. This one has an arrow. So this is going to the left forever until -2. So x is less than -2, and it does have a solid circle on that guy. So that's this whole red parabola shape here is that. All right, and you know what? I'm already in trouble because I'm thinking that's going to be a more complicated equation. So I had to leave a little more room. All right, then I'm switching. We'll say purple is this piece in here. That's a line, and it goes from -2 to +2. -2 x2 less than, and they're both open circles. so I don't need any or equal to's. And then we'll do green for this guy. This is a line. And that one is for x values greater than 2. And that one had a positive or filled in circle at x equals 2. So we're going to say or equal to 2. I probably should have put this on the video earlier because this is a pretty complicated one here. We have a parabola over here that is a u, so it is an x squared. The vertex is normally at 0, 0, and it goes up 1 and over 1. And when you square 2, it would be up to 4. So this one has been shifted left. 1, 2, 3, 4. Which is a plus. And it has not been shifted up or down or reflected. The question is, has it been stretched at all? And since it goes over 1, squared is 1, out 2, squared is 4, out 3, squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is not stretched, okay? So that's all we have for that guy. Is it's a parabola slid left 4. All right, then this is a linear equation, and we are in luck. We know the y-intercept is at 3, and it's going up 1 and over 2 is the slope. All right, the green one here is a little bit trickier. I might do this the long way just to show you again. Over 2 and up 1, 2, 3, 4, 5, 6. So it is going through 2, 6, and it is also going through 1, 2, 3, 4, 5, 0. So if I were to do the slope from there, I'd get -2 is a slope. Does that seem okay? Think you could have figured that out by hand? It's going down 2 and over 1. All right, then I'm going to use point slope. I'm going to go y minus 0 equals, I'm using this guy, -2x minus 5. So when I distribute, I get y equals -2x plus 10. So is that my prediction? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that seem like where it would cross if it were to continue? Seems right. So I have -2x plus 10 is the rule that it's following for that piece. Okay, I did it by hand, but you could have also just extended the line and figured it out. All right, that's the video. You're in luck. The assignment, I think, is all linear. There's no parabolas or square root graphs on your assignment for practice. And on the quiz, everything is multiple choice, so you just have to pick the right graph that goes with the function or the right function that goes with the graph. Thanks, guys. Have a good day.